Hey there, in this video we are going to see how we can convert a binary number into decimal. We are going to see it for both positive as well as negative numbers. So let's quickly get started. Now for conversion, for our examples, what I have done is I have written two numbers, 23 in decimal and minus 23 in decimal. Now by following the method that we have seen in the previous video, I have converted both these numbers into binary. So for plus 23 or positive 23, the conversion is 1 0 followed by triple 1. So this is the binary conversion of positive 23, and for negative 23, the binary conversion in 8-bit binary format is triple 1 0 1 0 0 1. So these are the two numbers that we are going to experiment with. Okay, so let me quickly start with the first number, which is 10111. We have to see how we can convert this 10111 back to 23. Okay, so let me just write it again over here, 10 followed by triple 1. Now just focus very carefully over here. See, we have multiple digits in this number, so I'll just draw these slots over here, and what we are going to do is we are going to give position to each and every digit of this number. So we'll start with position 0, then over here the position will be 1, then 2, then 3, and then 4, and so on till the time you have digits in your number. Okay, now each and every position is going to have some positional value. Now in case of binary number, see, this is a binary number, so in case of binary number, the positional value of digit is going to be 2 raised to the position number. So in this case, for example, for this digit, the positional value is 2 raised to 0. For this digit, the positional value is 2 raised to 1. Over here it will be 2 raised to 2, over here it will be 2 raised to 3, and over here it will be 2 raised to 4. See, in case of decimal, the positional values will be 10 raised to 0, 10 raised to 1, 10 raised to 2. I hope you have done this in your mathematics, right? So in case of binary, the positional value will be 2 raised to 0, 2 raised to 1, and so on. So now we have positional value for each and every position. Now it's very simple. Wherever you have 1, you have to write positional value below that digit. Okay, wherever you have 1 as a digit, you have to write positional value below that digit. So in this case, we have 1 over here, or 1 digit over here, and the positional value is 2 raised to 0, that means 1, so I'll write 1 over here. In this case also we have digit as 1, the positional value of this digit is 2 raised to 1, so I'll write 2 over here. See, in case of binary, we just have two possibilities, two digits. Either it can be 0 or it can be 1. So ideally what we do is we kind of multiply the positional value with digit at that position. But in this case, the digit is 1. So whenever the digit is going to be 1, the multiplication result is always going to be this number, the positional value, and whenever the digit is going to be 0, the result is always going to be 0. So in this case, the positional value is 2 raised to 2, which is 4. So I'll write 4 over here. Over here the value will be 0 because the digit is 0. So whenever you have digit as 0, the value you will write is going to be 0. And in this case, digit is 1 and the positional value is 2 raised to 4. So if you calculate 2 raised to 4, it is nothing but 16. So I'll write 16 over here, and then it's pretty easy for us. What we have to do next is we just have to sum up all these things. So if you add all these things together, 16 plus 4 is 20, 20 plus 2 is 22, and 22 plus 1 is 23. That's it. So we have the answer, that is 23. So in this way, you can convert any binary number back to decimal number. So this was easy, this was very easy for the positive number. Let's see how we can convert a negative binary number or a negative number back to decimal. So let's quickly start with this example. So let me write this number over here. So it is 111 followed by 0 followed by 1001. Now we have to do it in multiple steps for the negative number. So step number 1 is we have to take 1's complement. So step number 1 is taking 1's complement. Okay, so let's start taking 1's complement of this number. So in 1's complement, we know that 1 will become 0 and 0 will become 1. So the modified number or the 1's complement of this number will be 0001 0110. This is step number 1. That's it. We have got 1's complement. Step number 2 is we have to add 1 to this 1's complement. I hope these steps are looking familiar to you. These are very similar to how we used to do or the steps that we used to perform in decimal to binary conversion. It is very similar to that. So we have to add 1 to this 1's complement. So after adding 1 to this 1's complement, we have 1 1, or I'll say triple 1 0, and from here it will be the same. Okay, now if you observe this number very carefully, just ignore these zeros, because zeros or consecutive zeros on extreme left hand side doesn't make any sense. Okay, they are not of any use. So if you observe this number, just carefully observe this number, it is very similar to this number, and this is nothing but 23 or plus 23. This is the magnitude that we are getting for our negative number, and what you just have to do is you just have to add minus sign to this magnitude, and that's the way you will get your negative number back from the binary. So for getting negative number, or for converting negative number to decimal, what you have to do is, in step number 1 you have to first get 1's complement of it, then in step number 2 you have to add 1 to the 1's complement, and then whatever result that you are getting, you have to convert that result back to the decimal by following the same method that we followed over here. Okay, so by following the same method that we followed for the positive number, you have to convert the number that you are getting back to the decimal, and you just have to add negative sign in front of it. That's it. In this way your negative number will be converted back to the binary. So let's quickly revise how we can convert positive number back to binary. For each and every digit we will assign some position. Position will start from right hand side and it will go till left hand side till the digits that you have in the number. The position will start from 0, and each and every position is going to have a positional value. So it's going to be 2 raised to the position number. So in case of this digit, the positional value will be 2 raised to 0. For this digit it is 2 raised to 1. So in this way we can convert positive number back to decimal, or positive binary number back to decimal. How we can convert negative binary number back to decimal? You have to first take 1's complement of the binary number, then you have to add 1 to that 1's complement, and then whatever number you are getting, by following the same method that we follow for the positive number, you have to convert that number to decimal. You will get some number, you just have to add minus in front of it, you just have to add minus sign for it. In this way you are going to get negative number converted to decimal.